So in activity 5-1, we're going to learn where the distance formula comes from. And once we learn where the formula comes from, we're going to use that formula to find the distance between any 2 points. And the points are going to be located on a coordinate plane. So we start by plotting these 2 points. P is located at the coordinate 1, 4. So it looks like P is going to be right there. Call that point P. And Q is located at 13, 9. So we'll go up there and call that point Q. And I'm going to try to draw a straight line from there to there. Okay, so I got that done. Now it says, then draw it. Okay, so I've drawn PQ. I've done step number 1 right here. Step number 2, it says draw a horizontal segment, PR. So I've got to put an R on there somewhere. And they said a horizontal segment. So they want me to start at P and they want me to go horizontally. Okay, go horizontally. Until I get to a point R. Well, I've got 2 choices. I can go to the left and I can go to the right. That information all by itself would not be enough for me to draw PR. So it says, and a vertical segment QR. So they want me to go up and down for Q. So if I go up and down for either up or down to locate R from Q, and I have to go left and right to locate R from P. Now, R is only 1 point. So if I have to go left and right and up and down, I'm thinking that R needs to be somewhere right about here. So let me just, let's see. I'll just start right here and I'll go up this way. And then I'll go down this way. I'm going up and down from Q. I'm going to go left and right from P. And in order for R to be in one place that will take care of both of those, then it looks like R needs to be right there. So R is going to go right here. Okay, there's my R. Okay, so draw a segment, a horizontal segment, I did that. Draw a vertical segment, I did that with the right angle at vertex R. And yes, that is a right angle because anytime a horizontal line intersects with a vertical line, you get a right angle. I will go ahead and mark that as a right angle. And let's see, what else does it say to do? What is the coordinates of point R? Well, we're on a coordinate plane, so that's pretty easy to see that the coordinates of point R, the coordinates are 13 and 4. So R is located at the point 13, 4. Now they want to know what is the length of PR. Now, the length of PR is just a horizontal number line. So you remember from your lesson that gave you your ruler postulate. Your ruler postulate says that if you're on a number line and you want to find out how far apart 2 points are, what do? You subtract them. So we're on just the horizontal line. So the only thing we're paying attention to are the x coordinates because that's what's changing right here. And this x coordinate right here is the x value 1, and this coordinate right here is the x value 13. So in order to find out how big PR is, we're going to say 13, which is the right point, minus 1, which is the left point, and 13 minus 1 gives me 12. As y'all can see, I'm using a program that'll allow me to write on my web screen rather than cutting and pasting and going to the other page, and I'm trying to decide which way I like better. So anyway, and we could also, of course, just count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this segment right here is 12 units long. This piece right here. That's 12 units long. And then we could find this one. This one is a vertical line segment. And when we're changing along a vertical line, the only thing we look at are y values. So this y value right here is 4, and this y value right here is 9. So to find QR, it didn't like my R. You just have to draw really slow. To find the length of QR, you take the top point, which is 9, and you subtract the bottom value, which is 4, and 9 minus 4 is 5. So we find out that QR is 5 units long. Well, we could also count 1, 2, 3, 4, 5. Okay, and I believe the next thing it's going to ask us to do, explain how you determine your answers. Well, I've already explained that. I use the ruler postulate. Use the Pythagorean theorem. Okay, Pythagorean theorem says that to find the hypotenuse of a right angle, by the way, this was 5. To find the hypotenuse, the length of the hypotenuse of a right triangle, we take the length of one of its legs, which is 12, and you square it. And then you add that to the length of the other leg, which in this case is 5, and you square it. And you add those two together, and you will get the length of PQ squared. So what should we do? Call that C. A squared plus B squared equals C squared. Okay, so that is 144. And that is 25. And we add 144 and 25 together, and we get 169. And then 169 is the length squared of the hypotenuse. So if we want to figure out what the hypotenuse is, we have to unsquare it. And so the length of the hypotenuse is 13. I believe that you've already learned about Pythagorean triples. And didn't you learn a Pythagorean triple of 5, 12, 13? If you didn't, you should have. Make a note of that. That's a Pythagorean triple. So 5, 12, 13. So the length of this is 13. All right, so that's using the Pythagorean theorem. Now, if we, let's say they want you to do it again. No, same one. How do you know the triangle you drew is a right triangle? We already talked about that because the vertical line is always perpendicular to a horizontal line. Explain how you would find the distance between those 2 points. Well, in order to find the distance between those 2 points, we would do the same thing that we did. We would plot them. We would find how far apart the x values were, how far apart the y values were, use the Pythagorean theorem, and go from there. You guys can practice that. Check your understanding right here. Pause the video and make sure you can work those 2 problems. When after you pause that video, actually, I'm going to stop this video, and at the beginning of the next one, I will have those answers for you to check.